As we continue to look at relationships within triangles, our next lesson is going to be bisectors inside of triangles. Now these bisectors are going to come two ways. They're either going to be line segment bisectors or angle bisectors. This section and the one that follows will be very heavy in vocabulary, so make sure you're taking good notes and are keeping up. Our first is concurrent lines. Concurrent lines are defined as three or more lines that intersect at one common point. So from a diagram point of view, if we could take just any triangle and put another line that came in and intersected one of the vertices, then it would be concurrent with those two other lines. So as we go through and work with this, we're going to be talking a lot about the concurrent lines. Our first theorem in relation to this is the concurrence of perpendicular bisectors theorem. Now this theorem states the perpendicular bisectors of the three sides of a triangle are concurrent at a point equidistant from all three vertices. So if I were to take a basic triangle, could be any shape, scalene, equilateral, or isosceles, and draw a perpendicular bisector, and I'm going to sketch this, for each of the three line segments that make up this triangle, then all three of these perpendicular bisectors will meet at one location. And the distance from that location to any of the vertices will always be constant. Now this location is called the circumcenter of the triangle. And what the circumcenter is it is the middle of a circle that could be drawn that would touch all three of those vertices and not cross over them. It would just touch. It is inscribed inside, the triangle is inscribed inside of the circle. So this center, if you're trying to find a single location to build a structure that's the same distance from all places, let's say a college campus has a number of buildings for the students to be living in for dorms or working in for their classes. If you have three buildings that are all academic buildings and you want to put a new dormitory up that's the same distance from all of them, you simply sketch in your triangle and find the circumcenter, and that building location is going to be equal or fair for all students to be able to get to. Along with our bisectors of the angles, or bisectors of our line segments, so let's look at angle congruence. We have a congruence of angle bisectors theorem, number 5.7, and it states that the bisectors of the angles of a triangle are concurrent at a point equidistant from the sides of the triangle. Now again, what this means, that if I take any random triangle and I bisect each of the angles, so these come out congruent, these come out congruent, and so do the third set. If I had constructed this rather than sketching it, they would all meet at a single location, and that location, given perpendicular distances to the sides, will always be the same length. So this, and this are all congruent to one another. So if we're looking for the closest path, or closest item to a path of travel, we will be looking at this concurrence point. Now this location is called the incenter of, and this incenter location is one where we could draw a circle inside of our triangle that is going to be touching the three sides of the triangle without crossing over. So the circle will be inscribed in the triangle itself. So our circumcenter, the triangle is inside of a circle. Incenter, the circle is inside of the triangle, neither of which allow crossover of the other object. So let's use these to solve a problem that's been set up. Here we have triangle JKL, and we have the angle bisectors for two of these angles drawn out. We know from our given information up here on the right that the length of QN is 5x plus 36. The length of QM is 2x plus 51. I need to find the length of QO. Well, QN here and QM here are, by theorem 5.7, congruent to one another. So since they are congruent, that means that their lengths are going to be equal. So we have 5x plus 36 being equal to 2x plus 51. Solving this, subtraction property of equality, I can subtract 2x, give me 3x plus 36 equals 51. Next, again, subtraction property of equality, I'm going to subtract 36 from each side. That gives me 3x equals 15. Division property of equality, dividing by 3 on each side, x equals 5. Now again, do not stop here. This is not our final solution. I need to answer what the length of QO is. Again, QO is going to be that perpendicular distance, and it will be equidistant to either QN or QM. So if I find out what one of those are, the other one will be the same thing. I choose to use the second equation for QM. So I have, using substitution, 2 times 5 plus 51. 2 times 5 is 10, plus 51 is 61. The length of any of these three line segments from Q out to the sides is going to be 61 units. So check over these, make sure you have the vocabulary and the theorems down, because we're going to be using these as we advance.